Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A Level Mathematics 9709 Mechanics. So today we will be continuing with some more practice questions related to chapter 1. So let's get started. Now this is a question from November 2008, paper 4, question number 6. A train travels from A to B a distance of 20,000 meters taking 1000 seconds. Okay, so the total distance between A and B is 20,000 meters, taking 1000 seconds. The journey has three stages. In the first stage, the train starts from rest at A and accelerates uniformly until its speed is v meters per second. In the second stage, the train travels at constant speed v meters per second for 600 seconds. During the third stage of the journey, the train decelerates uniformly, coming to rest at B. Okay, so let's underline some of the important information. We know that the distance from A to B is 20,000 meters. So let me draw a diagram. Now understand something. It is very important that you draw a short, quick sketch of what the situation is. Okay, it is very important to visualize the situation so that you are able to see that what quantities you have and what calculations you need to do. Okay, you will also be able to identify what are the missing information that you need to find out first. Okay, so we know that this is 20,000 meters, and we know that t is equal to 1000 seconds. So that's the total distance and the total time of the journey. Now, if you divide them into three stages, it says the first stage, it starts from rest at A. So that is 0 meters per second. Okay. Then it accelerates uniformly until its speed is V. In the second stage, the train travels at constant speed V meters per second for 600 seconds. Then during the third stage of the journey, the train decelerates, coming to rest at B. Okay, so if I were to write them down, all this information, so we can see that there are three stages. So let's say that it starts at A and over here it's at rest position. Okay, so that means the velocity is 0 meters per second. Then it travels all the way and achieves a speed of v meters per second. The duration that this takes, that is unknown. We don't know how much time it takes. Okay, that is the first part of the journey. Second part of the journey is that now it is at v meters per second and it is traveling at this velocity, at this constant velocity for how much time? Let me double check. For 600 seconds. Okay, so we know that the duration for this part of the journey is 600 seconds. Then the third part of the journey, from v meters per second, it comes to rest. So that is 0 meters per second, and this is rest at B. Okay. Now, how much time is this going to take? Now we know that the total time taken is 1000 seconds. Out of 1000, if I subtract t, okay, and if I subtract 600, whatever remaining time will be there, that will be the duration for the third stage of the journey. So that means I'm going to write down 1000 minus t minus 600. So that gives us 400 minus t. 400 minus t seconds. Now that's all what I know. Now the first part of the question is sketch the velocity time graph for the train's journey. All right. So I need to draw a velocity time graph. Okay. Now, so this is velocity. Okay, and the units will be meters per second. Make sure that you label the axis properly along with the units. Okay, this is time and the unit is seconds. Okay, now we know that during the first part of the journey, it starts from rest Okay, so the graph is going to start from here, and then it travels in straight line. It accelerates uniformly, right? So uniform acceleration means that is going to be a straight line. The velocity that it reaches is going to be v. All right. Now it stays at this constant speed. Sorry, the time taken is t, and that's 0. Now it stays at this constant velocity for 600 seconds. So that means the time over here is going to be 600 plus t. Then it decelerates uniformly. So that's how the graph should be. And the time over here is going to be the total time of the journey, which was 1000. All right. So yeah, I think that's pretty about it. That's pretty much about it. So that's a velocity time graph that we have sketched. Then it says find the value of v. Okay, so this is the first part. Now in second part, we need to find out the value of v. So at the beginning of the question, it stated that the total distance from A to B is 20,000 meters, right? And if I look at velocity time graph, I know that the area under the graph is equal to the total distance traveled, right? So therefore, we can say total distance is equal to area under the graph. So clearly we can see that this is a trapezium. So I'm going to apply the formula of trapezium. The sum of parallel sides. So the first side is going to be 1000 plus the difference between this point and this point is going to be 600 plus t minus t. Okay, so that is the sum of parallel sides multiplied by the distance between them, which is v. Okay, now we know that the total distance is 20,000 meters, so I can fill up this value over here. Now t and minus t, they'll be cancelled out. So we have 20,000. So I can multiply this 2 on the other side so that this becomes 40,000 equals to 1000 plus 600. That'll be 1600 V. Therefore, V is equal to 40,000 divided by 1600. Two zeros cancel out. 400 divided by 16 will give us, let me calculate that, 25 meters per second. Okay, so that is the velocity. So let's move to the third part of the question now. Now it says, given that the acceleration of the train during the first stage of the journey is 0.15 meters per second squared, find the distance traveled by the train during the third stage of the journey. Given that the acceleration during the first stage of the journey is 0.15, find the distance traveled by the train during the third stage of the journey. Okay, so the main question is that we need to find out how much distance was traveled during the third part of the journey. Okay, if I look at the graph, so this is what I need to find, right? This is the distance that I need. So clearly this is a right angle triangle, so I'm going to apply the formula half into base into height. So I know what is height because now I have found the value of velocity, which was 25. But the thing is, I cannot calculate the distance until I find the value of t, because that will give me the base. Okay, so that means first I need to find out what is the value of t. Now the question says that given that the acceleration during the first part of the journey, which is this one, is 0.15 meters per second square. So using the formula that acceleration is equal to change in velocity over change in time, I'll be able to calculate the value of t. Okay, so We know that acceleration is equal to change in velocity over change in time. So the value of acceleration that's given is 0.15 equals v, which is 25 minus 0, and t minus 0. So therefore, t will be equal to 25 divided by 0.15, and that gives us 500 over 3 seconds. Now, because this is not my main answer, right? So I don't need to round it off. I can use the exact value in my subsequent calculations. Okay, so this is still the intermediate calculation going on. So I don't have to round it. Okay, now we need to find out the distance traveled. So distance traveled during the third stage is equal to half into, now our base is going to be the difference between these 2 points, right? So 1000 minus 600 minus t, 1000 minus 600 minus t, and our height is going to be the value of v, which is 25. So this will be half into 400 minus t times 25. So that will be half into 25 times 400 will be 10,000 minus 25t. Sorry, my bad. We already found the value of t, right? So we can just plug in that value now. So this will be 500 over 3 multiplied by 25. Okay. So, right. So now 25 times 500 upon 3. This will be 12,500 over 3. Now I can plug all of this in calculator. Look, the thing is I could have plugged all of this in calculator, right? But the thing is that you should show some working. Don't just put everything into a calculator and then work out the final answer. It's better to show some steps. So 1 upon 2 times 10,000. No, just a minute. This should be in the bracket, right? Right. So now we're going to put this in a bracket and then we're going to calculate. So our answer is going to be 8750 over 3, which when we round off to 3SF will give us 2920 meters. Okay. If I don't round it off, so basically I'm gonna get 667. Okay, and now if I round it off to 3SF, so that will give me 2920. So that is the end of our first question. Let's move to second question now. This question is from November 2013, paper 43, question number 5. A car travels in a straight line from A to B, a distance of 12 kilometers, taking 552 seconds. So again, from A to B, we know the total distance, we know the total time. The car starts from rest and accelerates for t1 seconds at 0.3 meters per second square, reaching a speed of v meters per second. Okay, so let me just draw this first. So between points A and B, we know that the distance is 12 kilometers, and most likely we will be doing our calculations in meters. So I'm going to convert this into meters. Time is equal to 552 seconds. Okay. Now the first part of the journey is that it is at rest at A, that is 0 meters per second, and then it reaches velocity v meters per second. All right. Now the acceleration during this part of the journey is 0.3 meters per second square. Okay, that's all that we know about the first part of the journey. The car then continues to move at v meters per second for t2 seconds. Okay, also this is t1 seconds. Now in the second part, it remains at constant velocity of v for t2 seconds. Okay, and obviously acceleration is going to be 0. It then decelerates to, sorry, it then decelerates for t3 seconds at 1 meters per second square, coming to rest at b. So in the third part of the journey, it's now decelerating from v meters per second to rest at b, which is 0 meters per second. Okay, that is t3 seconds, the duration, and acceleration. Now because the deceleration is 1, acceleration will be minus 1.00 meters per second square. Okay, so that's all that we know about the 3 stages of the journey. Now the question is sketch the velocity time graph for the motion and express t1 and t3 in terms of v. So there are two parts of the question. So let us deal with the first one. Sketch the velocity time graph. Okay. All right. So this is our part one. This is velocity with the units meters per second, and this is time with the unit seconds. So again, the journey starts from 0, goes all the way up. All right. And this is t1 and this is v. Then it says during the second part of the journey, it remains constant for t2 seconds. Okay, so now it says for t2 seconds. So he has given us the duration, but what will be the time at that point? The time will be t1 plus t2. So t2 is the duration for this part of the journey, but the actual time is going to be the sum of these two times, right? All right. After that, it decelerates and reaches this point. So let me just extend this a little bit, or let me just add up a line. Okay. Now the time over here is going to be t1 plus t2 plus t3. Why? Because the duration was t3 seconds. So the time at that particular point will be the sum of all the times, isn't it? And the sum of all that time is actually equal to 552 seconds because that was given to us. All right, so you can see it says that taking 552 seconds for the entire journey. So I'm going to write just 552 seconds. But keep this in your mind that this is t1 plus t2 plus t3 equals to 552 seconds. So that is the first part of the question. Now the second part, it says that express t1 and t3 in terms of v. Okay, so we need to express t1 and t3 in terms of v. All right. Now t1 is the time during the acceleration. Okay, so we know what the acceleration is, isn't it? It was given to us that it is 0.3 meters per second square. So I can use the value, sorry, I can use the formula. Acceleration is equal to change in velocity over change in time. Acceleration is 0.3. change in velocity, that will be v minus 0, and this will be t1 minus 0. So t1 is equal to v over 0.3, which is equal to 10 over 3 v seconds. Okay, that is t1 expressed in terms of v. Similarly, we can also do the same thing for the third part of the journey, which is t3. Okay, the acceleration was -1, and this is v minus 0. Sorry, my bad. 0 minus v, because now the final velocity will be 0 and the initial velocity is v, because now we are talking about what? The third part of the journey. So here final velocity is 0, initial velocity is v, and our duration will be t3 seconds. Okay, now because the duration is t3 seconds, so I don't have to subtract from anything, right? Because that is already the change, isn't it? Between 552 and t1 plus t2, the change between them is already t3, so therefore I don't need to write down the entire subtraction. So here it will be t3 is equal to minus v over minus 1, which is equal to v seconds. So that is our answer to part 1. Now let's move to part 2. Express the total distance traveled in terms of v and show that 13 v square minus 3312 v plus 72,000, okay, so this is a quadratic equation, equals to 0. Hence find the value of v. So first we need to express the total distance traveled in terms of v, and that should equal to this equation. Then we need to solve this equation. We need to find the value of v, so definitely we'll be using the quadratic formula, because these are big numbers. So instead of factorizing them, it is better to just use the quadratic formula. All right, so because it says express the total distance traveled, it has already given us the hint, right? That what is the next step? We need to find the area under the graph. So that will be distance traveled equals area under the graph. So that will be half into sum of parallel sides. So now let's see. The first one is going to be 552, and the second one will be t1 plus t2 minus t1. So 552 plus t1 plus t2 minus t1. So these are the sum of parallel sides multiplied by v. Okay, because that will be the height of the trapezium. Now the distance traveled was already given to us at the beginning of the question, which was 12,000 meters. It said 12 kilometers, right? And we already converted into 12,000 meters. So now I'm going to multiply this 2 on the other side so that this becomes 24,000 equals, from here T1 and T1 over here. So this will be cancelled. We're going to get 552V multiplied by, sorry, plus V T2. All right. Now, because we need to express our equation in terms of V, it is important that I should calculate that what is T2 as well, right? What is T2 in terms of V? All right. So let me use a different color for this spot. So now we need to express T2 in terms of V. Okay. So now we know that T1 plus T2 plus T3 equals 552 seconds. T1 was already expressed in terms of V as 10 upon 3V plus T2, and T3 was expressed as V equals to 552. So I got these values from here. So T1 is 10 over 3V and T3 is V. Okay. Now I'm going to make T2 the subject of the formula. So this becomes 552. Now 10 over 3 plus 1. That will give us 13 over 3. 13 over 3v, and when I shift it to the other side, I'm going to get minus 13 over 3v. So that is T2. Now substituting this back into T2, I'm going to write this down as 24,000 minus 552v plus v times 552 minus 13 over 3v, 24,000 minus 552v plus 552v minus 13 over 3v squared. Okay, right, this is 552v. So 24,000, and also I think this is equal, my bad, equals 552 plus 552. So that should be equal to 1104v minus 13 over 3v squared. So now first I need to get rid of this 3. So I'm going to multiply both sides by 3. So 3 times 24,000 gives us 72,000, and 3 times 1,104 gives us 3,312v minus 13v squared. Now clearly I don't want a negative on my v square, right? So I'm going to shift both of these values on the other side. So therefore my equation becomes 13v squared minus 3,312v plus 72,000 equals to 0. So now they already gave us the this equation, right? So let me just double check. This is 13, then 3312, 72,000. Okay, 13, then 3312, 72,000. Perfect. Okay, now we need to solve this equation. So for this purpose, definitely I'm not going to sit down and look for factorization because these are huge values. So instead, what I'm going to do is I'm going to apply the quadratic formula. I'm going to use the quadratic formula for this. So what was quadratic formula? X is equal to minus b plus minus b squared minus 4ac under root divided by 2a. Okay, so in our case, this will be minus times minus 3312 plus minus minus 3312 whole squared minus 4 times 13 times 72,000. Let me just pull this back a little bit over here. All right. So this comes under root over 2 times 13. Now, usually the students have a little bit of concern that how much working are we supposed to show? Like, is this much enough and then just plug everything in calculator? I would say no, just you need to show one more step and before you put everything in calculator. That one more step should be, this becomes 3312 plus 2 times 13, that is 26, right? Now, whatever answer you get from here, just write that down. So let me write this down. 3312 whole square minus 4 times 13 times 72,000. Okay, that gives us exactly 2,688. Let me just plug in my charger first. All right, so that is the first solution. The second solution will be 3312 minus 2688 divided by 26. That is how much working you have to show. Now plug everything in calculator to give you the solution. So this will be 3312 plus 2688 over 26. So that will be 230.6 0.769, and on the other hand, this gives us exactly 24 meters per second. Okay, so now here we have two solutions to this equation, right? Now clearly, this one is not it's not a realistic value, right? To get 231 meters per second, right? So that's not a realistic answer. So therefore, v is equal to 24 meters per second. That is going to be our final answer. All right. Now, that is the end of our question number two, and that is also the end of our video. So I hope that you got a flavor of some more kind of questions, little bit of questions that involved some more algebra, like dealing with quadratic equations. So this was a nice question. All right, so in our next video, we'll be starting with chapter number two, and we'll be looking at some of the most important concepts that are used in relation to constant acceleration, which are the equations of motion. Okay, so we will see how those equations are derived and how we use them in calculations. Knowing these equations, they help a lot in simplifying our calculations, in finding values in a much more efficient manner. So we'll be looking at those aspects in our next video then. Till then, take care. Assalamu alaikum.